recap before we conclude. So, let's get started. Before we dive into the details, let's outline the objectives of this presentation. By the end of this session, you will be able to file and finish mating parts within plus 0.02 mm using OS micrometer. File and finish mating parts having angular surfaces within plus minus 10 minutes accuracy using vernier bevel protractor.
Hacksaw frame. Flat and triangular file set. 3 mm drill bit and 15 mm drill bit. Drilling machine. Hammer. Vernier caliper. Micrometer. Die square. Needle file set. Vernier height gauge. Surface block. Center punch. Prussian blue. Scribber. Cotton waste. Lubricating oil. Task 1. File the surface and two adjacent edges at right angle to each other. Check the squareness. Refer the job drawing and do the marking as per the dimensions given figure 1. File the excess material and maintain the dimension 60 by 48 mm with vernier caliper. Check the squareness with square head. At this stage, make 6 relief hole in the corners by 3 mm drill. To make the hexagonal cutout, drill a 22 or 23 mm diameter. Drill hole in the center. File the hexagonal shape with a square file or triangular file. Finish the hexagonal shape and check the angle by the help of protractor head. 120 degrees. Task 2. Check the dimension inside and parallelism of faces with a vernier caliper. File the end of the given rod at right angle to the axis. File the end of the given rod at right angle to the axis. Mark the hexagon as per the dimensions given in the drawing figure 3. File one side up to the marked line. Check the parallelism throughout the length. File the adjacent side and check the angle, 120, by protractor head. File and finish the other sides, also figure 4. Finally, check the flat dimension and other sizes and assemble in the hexagonal slot. Place the female part on a wooden block. File and finish both surfaces with a smooth file and maintain the thickness. Remove the burrs from the edges. Check for hexagon slide fitting.
We discussed the objectives of this presentation, which included understanding the concept of hexagonal slide fitting, identifying the tools required, learning the step-by-step process, and discovering best practices. A hexagonal slide fitting is a type of closure mechanism that utilizes a hexagonal shape to secure and fasten two parts together. It is designed to provide a secure and reliable connection between components. The closure is typically created through a design process using CAD software, followed by prototyping and manufacturing. The final product is tested to ensure it meets required standards for strength, durability, and compatibility. The hexagonal slide fitting closure offers a versatile and effective solution for joining and securing components in various applications. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care.
Hello students, now we shall discuss how to prepare different types of documents as per industrial requirements by different methods. Objectives: to learn about how to prepare and fill up batch processing record in format, bill of materials, production cycle time in format, daily production report in format, manufacturing stage inspection report format. First of all, study different types of documentation provided in formats. For data collection, please visit to the industry and collect the input and information and fill it up in all the formats provided. Prepare the required format with the knowledge gained during the industrial visit. Record relevant information in the format. Get it checked by your instructor or training officer.
Batch Processing Record, Format 1. The purpose of this document is to maintain record of the batch produced during the manufacturing process. For filling information in the document, please follow the stepwise procedure. A. Batch details. B. Staff details. Remarks. Any specific and or noteworthy events occurred during the entire process to be mentioned here. Bill of Material, Format 2. The purpose of this document is to maintain record of the materials consumed during the manufacturing process. For filling information in this document, please follow the stepwise procedure mentioned below. A. Details of materials consumed. Please fill serial number-wise details regarding item number, description, quantity, relevant reference, drawing number, standard of the material used and remarks, if any. Production Cycle Time, Format 3. The purpose of this document is to maintain record of the production cycle time to improve operational efficiency. For filling information in this document, please follow the stepwise procedure mentioned below. A. Organizational data. B. Staff details. C. Execution details. D. Notes. Any specific and noteworthy comments to be mentioned here, if any. Daily Production Report, Format 4. The purpose of this document is to maintain record of daily production to report manufacturing cycle progress on daily basis. For filling information in this document, please follow the stepwise procedure mentioned below. A. Routine details. B. Record of work. C. Authorized signatory should sign the document after verification of the filled details. Manufacturing Stage Inspection Report, Format 5. The purpose of this document is to maintain record of the inspection of the work carried out during various stages of production process. For filling information in this document, please follow the stepwise procedure mentioned below. A. Routine details. B. Stage-wise record of work. C. Finally mention the inspection record number with date and name, sign of the inspection or test conducting personnel with date.
Now, we shall discuss how to prepare different types of documents as per industrial requirements by different methods.
First of all, study different types of documentation provided in formats. For data collection, please visit to the industry and collect the input information and fill it up in all the formats provided. Prepare the required format with the knowledge gained during the industrial visit. Record relevant information in the format. Get it checked by your instructor or training officer. Please provide the undermentioned forms to the students in blank. Job card format. The purpose of this document is to maintain record of the customer-wise work carried out during the entire production process from start to end. For filling information in this document, please follow the stepwise procedure mentioned below. A. Routine details. B. Stepwise record of work. C. It is also necessary to document the total time for which the manufacturing location has been engaged. D. Note down the remark if there are any important points to be noted. Work activity log format. The purpose of this document is to maintain record of the workman's activities during the manufacturing process for enhancing overall productivity. For filling information in this document, Please follow the stepwise procedure mentioned below. A. General details. B. Duty time-wise record of activities. C. Note down the remarks if there are any important points to be noted. Batch production record format. The purpose of this document is to maintain record of the batch handled during typical product manufacturing process. For filling information in this document, please follow the stepwise procedure mentioned below. A. General details. Please fill the routine details such as name of the manufacturing organization, department and sections, etc. B. Process batch-wise record of activities. Estimation sheet format. The purpose of this document is to report the estimated time required for completion of the manufacturing process for efficient production planning and control. For filling information in this document, please follow the stepwise procedure mentioned below. A. General details. B. Operation-wise record of activities. C. Authorized signatory. Maintenance log format. The purpose of this document is to maintain record of the maintenance carried out on the machines utilized for production process. For filling information in this document, please follow the stepwise procedure mentioned below. A. General details. B. Record of repairing activities. Machinery and equipment record format. The purpose of this document is to maintain record of the machinery and equipment utilized during the manufacturing process. For filling information in this document, please follow the stepwise procedure mentioned below. A. General details. Please fill the routine details such as name of the organization, department, section, etc. B. Machine-wise record of activities. C. Dimensions of the machine such as length, width, height, weight, etc. are also to be noted down. Preventive maintenance record format. The purpose of this document is to plan preventive maintenance schedule of the machines utilized during the manufacturing process. For filling information in this document, please follow the stepwise procedure mentioned below. A. General details. B. Report of machine inspection. C. Authorized signatories.
Recap. Dear students, I hope now you have understood how to make and use different forms according to requirement. Dear students, in this session, we shall study how to make the round sections, their finishing, size checking and verification. This shall be discussed in two parts, part 1 and part 2. Objective. At the end of this task, you shall be able to mark and file spline on the shaft, mark and file internal spline in the hub, file and assemble hub and spline shaft. First of all, check the raw material size using steel rule and file the raw metal to overall size part 1 28 to 50 mm diameter and part 2 50 to 50 mm diameter. Next, apply marking media on part 1 and part 2 and mark off spline keyways on part 1 and 2 by keeping on V blocks using vernier height gauge and tri-square as per job drawing. Now, punch witness mark on part 1 and part 2. Similarly, enlarge the pilot hole using different diameter drill and finally drill 20 mm diameter and enlarge the hole. Further, hold the job in benchwise and file keyway slot to size 10 mm width into 4 mm depth using square file bastard, second cut and smooth grade of file. Similarly, file other 3 keyway slot to the size as per job drawing. Check the keyway slots sizes using vernier caliper and finish file on part 1 and part 2 as shown in job drawing and slide it. Now, cut and remove the excess metal in part 1 by hacksawing and chipping and file to size and shape using flat file, safe edge file, square file and half round file bastard, second cut and smooth grade of files. Further, check the spline shaft size using vernier caliper. Finally, hold the part 2 in drilling machine table. Fix center drill in drilling machine spindle. Drill center drill to locate center of the round rod. Remove center drill and fix 6 mm diameter drill in drilling machine cylinder and drill pilot of the hole. Apply thin coat of oil and preserve it for evaluation. Now, we shall discuss how to mark a job using vernier height gauge. First of all, clamp the finished turned rod in the V block with the help of the clamps and make marks on both faces of the job. Then, set the scriber point on the top edge of the job and move the height gauge scriber over the round surface to get a feel that the scriber bottom faces is contacting the work periphery. Later, lock the slides and note down the reading of the scales. Next, subtract half the diameter from the reading and set the height gauge for that reading and scribe a horizontal line on both faces. Now release the workpiece from the clamp and rotate the workpiece through 90 degrees. Set the line at 90 degrees with the help of tri-square. Finally, clamp the workpiece to the V block and scribe horizontal lines on both faces with the same reading which is set for center position. Now add eccentricity amount to the above reading, reset the height gauge for the new reading and scribble horizontal lines on both faces. Release the workpiece from the V block and punch mark on both sides concentric and eccentric center points. Now, we shall discuss how to check parallelism using dial test indicator. For checking parallelism and flatness of surfaces, dial test indicators are mostly used. Procedure. Assemble the dial test indicator on the stand. Ensure that the surface plate and the dial test indicator stand base are cleaned. Remove burrs from work surface and clean. Check the free movement of the plunger.
Place the workpiece below the dial test indicator and set the plunger. A half-ton pressure of the pointer will be adequate. The plunger should be perpendicular to the work surface.
Unlock the bezel clamp, set the reading to 0. Slide the workpiece on the surface plate below the dial test indicator. Note the reading. Repeat the same step at 3 places longitudinally and transversely. Note the reading and determine the differences. Precautions. Do not apply oil on the plunger of the dial test indicator. Avoid sudden jerks to the plunger.
Students, I hope now you have understood the repairing techniques like mark and file spline on the shaft, mark and file internal spline in the hub, file and assemble hub and spline shaft.
Hi trainees, welcome. In this session, we will be learning about identify pneumatic components, construction and working principle of air compressor. At the end of this session, you will be able to get a clear knowledge about the construction, parts and working principle of air compressor which are employed in pneumatic system, and also we should know the different important equipments engaged in this system like FRL, that is filter, regulator and lubrication unit, different types of pneumatic valves and actuators, pneumatic cylinder.
Air compressor is a main equipment and it plays major role in pneumatic system. We know the compressed air is main working medium of pneumatic system and it has to be supplied continuously by the compressor. Apart of pneumatics, it also plays major role in many of engineering machines. Too many parts like cylinder, pneumatic valve, regulator valve, drain valve and motor are used to work the compressor efficiently. For best output, the air compressor must be working in its optimum power and efficiency for the effective output of the system. There are many parts in the compressor. let us have a detailed look on these. Motor. An air compressor needs an electric motor to power up the machine. The motor basically drives two belts, a pulley which allows the transfer of power from the motor to the pump pistons, and this is done through a flywheel and a crankshaft. One important thing need to install will be a magnetic starter to prevent the motor from overload. Tank. This is the compressor part that stores the air being compressed. It is the biggest part of the air compressor and it can range from 1 to 10 gallons or even more for bigger construction needs. The tank is generally made of steel. Pressure switch. The pressure switch automatically shuts down the motor when the receiver reaches the factory set limit. Once the pressure level drops to a preset level, then the pressure switch restarts the motor, therefore resuming the pumping of air by the compressor. It also acts as an emergency switch that regulates how much pressure in the tank can take. Drain valve. As the name implies, it drains the oil, dirt, moisture and other debris that might be trapped inside the tank. Simple maintenance of air compressors entails draining a tank from impurities and debris from use. Commonly used to avoid corrosion produced due to moisture and oil flag. Pressure gauge. This gauge measures compressed air pressure inside the tank of the air compressor. If the air pressure measurement is higher than the regulated normal limit, it gives a warning signal to inspect the air compressor or stop the compression before the gauge reaches even higher pressure. On the contrary, if the pressure reading is very low from the normal allowed measurement, it also indicates a problem with the compressor, such as a leak in the tank. This should also be checked right away to avoid any more complications and accidents. Inlet port. This port is used to guide the inlet air towards the compressor inlet valve. Inlet valve assembly. Inlet valve assembly contains valve plate and valve spring. Inlet valve controls the flow of air towards the cylinder of compressor. It is opening downwards to allow the air inside when the piston moves downwards. Valve plate is used to hold the inlet valve in proper position. Cooling fins. Cooling fins are the extended part provided from the cylinder body to assure heat transfer from cylinder to surrounding. Generally, these are made of aluminium. Discharge port. It is the opening provided at the top of compressor cylinder to guide discharge air towards the discharge line. Discharge valve assembly. It has discharge valve, valve plate and valve spring. Valve plate helps to hold the discharge valve in proper position. Valve is aimed for discharging the high pressure air when the piston reaches its top. Air filter. Air filter is very important part in an air compressor. It helps to prevent the dirt and dust to enter inside the compressor cylinder. Filter is provided in the suction end of the compressor. Safety valve. A safety valve is provided on the air storage tank or air outlet line to avoid accidents due to the air pressure that reaches beyond the capability of storage tank capacity. Regulator. Generally, an air regulator is provided in the discharge tube to regulate the high pressure airflow. Check valve or non-return valve (NRV) and unloaded tube. An one-way check valve is provided in the bypass line in between air receiver tank and compressor head. It will open and admit the high pressure air towards the receiver tank while unloading is going on during the starting time. An unloaded tube is connected at the inlet port of the check valve, and the valve only opens in one direction, that is, from compressor top to receiver airflow. During this time, the high pressure air is unloaded towards tank through unloaded tube. Compressor fan. A compressor fan is connected at one end of the crankshaft to provide sufficient cooling air to compressor. It will prevent overheating of compressor. Air compressors collect and store air in a pressurized tank and use pistons and valves to achieve the appropriate pressure levels within an air storage tank that is attached to the motorized unit. There are a few different types of piston compressors that can deliver even air pressures to the user. Automotive compressors are combustion engine compressors that use the up and down stroke of the piston to allow air in and pressurize the air within the storage tank. Other piston compressors utilize a diaphragm, oil-free piston. These pull air in and pressurize it by not allowing air to escape during the collection period. Air compressor is capable of building extreme pressure in storage tanks capable of storing enormous amounts of pressurized gases for industrial use. Let us have a look at the compressor. Identify the various components employed in a typical compressor. Just record and check over the identity of the noted names. Let us now have a look at the filter, regulator, lubricator, FRL unit. FRL assemblies are pre-packaged or modular assemblies of air filters, pressure regulators and lubricators. Air leaving from a compressor can be dirty, moist and also with some other foreign impurities having huge pressure variations. If these are not cleared, it results in damage of entire pneumatic system. In FRL unit, the filter unit having absorbent filtering element is to filter the previously mentioned impurities. After this, the regulator unit controls the pressure of air passed over into the system. Finally, the lubricator unit gives fine mixing of atomized lubricant to this pressurized air. Due to this, the moving parts in the system get lubricated, increasing the life and efficiency of the equipments. Valves are the devices used to control, regulate, commence, terminate, or change the direction of flow and pressure of fluid used in the system. Valves in pneumatics are grouped according to their function. They are directional control valves, non-return valves, pressure control valves, and flow control valves. Pneumatic actuators are the devices used for converting pressure energy of compressed air into the mechanical energy to perform useful work. Pneumatic cylinders can be used to make linear, rotary, and oscillatory motion. There are three types of pneumatic actuator. They are linear actuator or pneumatic cylinders, rotary actuator or air motors, and limited angle actuators.
We have reached the end of this session on Identify Pneumatic Components, Construction and Working Principle of Air Compressor. By now, you should be able to know the construction, parts and working principle of air compressor which are employed in pneumatic system, and also we should know the different important equipments engaged in this system like FRL, that is filter, regulator and lubrication unit, different types of pneumatic valves and actuators, pneumatic cylinder. Hello, welcome to this session on Dismantle, Repair, Replace and Assemble FRL or Filter, Regulator and Lubricator Unit. By the end of this session, you will be able to know about the FRL unit and list the types of FRL and its specifications, and also able to overhaul the FRL unit and mount and check the read pressure on the pressure gauge.
Filter, regulator and lubricator. FRL unit is one of the most important equipment in the pneumatic system. It is the combined unit. It removes dust and moisture, regulates the pressure, and also lubricates the dried air supplied to the system. Due to this, the system equipment life is increased and also ensures efficient working of system. Air leaving a compressor is dirty and wet, and it will cause damage to equipment and tools if it is not filtered. The filter cleans compressed air by trapping solid particles and separating liquids such as oil and water that are trapped in the compressed air. Filters are installed in the air line upstream of regulators, lubricators and all pneumatically powered tools and equipment. They remove contaminants from pneumatic systems, preventing damage to equipment and reducing production losses due to contaminant-related downtime. Pressure regulators control fluid pressure in compressed air systems. Regulators are also known as pressure-reducing valves or PRVs. Pressure regulators maintain a constant output pressure regardless of input pressure variations and demands made on the system by downstream components. Lubricators add controlled quantities of oil into the compressed air system to reduce the friction between moving components within air tools and other equipment that are powered by the system. The process of adding atomized spray of lubrication oil mixed with compressed air, which entering into the system also clears compressor oils that travel through the system in vapor form. To prevent the buildup of oil within system components, mineral oils are added to the system to flush away the deposits. Downstream equipment flow and pressure requirements determine the correct regulator and lubricator for the application. Manufacturers offer flow characteristics charts on their products to help choose the correct combination of regulators and lubricators. You now know how FRL unit works and its uses. Let's now see the types of pressure regulators. There are several choices for pressure regulator, and the various types of regulators are general purpose regulators, high pressure regulators, low pressure regulators, differential or bias regulators, and pressure reducing valves. General purpose regulators are designed for typical industrial use. They generally operate only above atmospheric pressure. High pressure regulators are rated for inlet pressures higher than general purpose, typically over 1000 psi. Low pressure regulators have special design characteristics for precise control of pressures, typically below 15 to 20 psi. Differential or bias regulators maintain a pressure differential between two locations in the system. Pressure reducing valves provide a sub-circuit with a supply of fluid at a pressure that is less than the pressure in the main circuit. Let's now see the performance specifications. The regulating or the adjustment range dictates the limits of adjustment control. If the primary application is liquid, then the maximum gas or oil flow is unnecessary to specify. The maximum pressure rating refers to the pressure rating for the valve or inlet pressure for the regulator. The filter minimum particle size rating applies to filter, regulator, and lubricator assemblies. It is the smallest size particle that will be entrapped by the filter. This rating is an indication of the largest opening in the filter element. The other important factors that should be considered with the specifications of regulator valve that includes regulator type, medium, adjustment control, connectors or pipe size, body material and environmental parameters. You will now be able to define FRL unit and state the types of FRL and their specifications. Let's now see how you can overhaul the FRL unit, mount and read the pressure on the pressure gauge. Let's see how to overhaul FRL unit and lubricator. First, you need to drain the water from the filter unit. Then, drain water from lubricator by rotating drain plug. Now, hold the filter bowl with hand and unscrew it. Do not use pipe wrench since bowl is mostly of plastic or alloy material and may break or damage. Now, use a spanner and remove the filter insert and rinse the filter in clean kerosene. Filter inserts are made of some ductile elements, so it has to be removed and cleaned carefully. Next, the inner side of the filter is blown by using compressed air. Rinse the bowl in soap solution and dry it with a clean cloth and place the filter insert and tighten the nut to the specified torque limit. Screw the bowl to the housing and confirm the drain plug is in closed condition. Let's now see how to overhaul a lubricator of FRL unit. Hold the lubricator body and unscrew the bowl by hand and drain oil from bowl. Then clean the bowl and rinse it in soap solution and dry it with a clean cloth. Then clean the filter at the tip of the dip tube. Ensure dip tube in its location after the O-ring is placed in its position. Then screw the bowl into its position tightly and open the inlet valve. Now observe the pressure gauge. Fill it with correct grade of oil as per manufacturer's recommendation to the level marked and maintain the oil level. Do not fill above or below the marked level. Clean and check the body to ensure there is no oil leak. Mount the FRL unit on the trainer kit. Ensure the flow of air is in line with the arrow mark on the FRL unit. The needle of the pressure gauge indicates the pressure on the dial behind it. Pressure is measured in kilogram per square centimeter or kilogram force per square centimeter.
We have reached the end of this session on dismantle, repair, replace and assemble FRL unit. You should now be able to know about the FRL unit and list the types of FRL and its specifications, and also able to overhaul the FRL unit and mount and check the read pressure on the pressure gauge. Hello, welcome to this session on safety procedures in pneumatic systems. By the end of this session, you will be able to follow the safety while working in pneumatic system, select the personal protective equipment, plan pneumatic maintenance practices and select proper practices of pneumatic maintenance.
Let us look at the safety procedures in pneumatic systems. Should not operate pneumatic machine without knowledge. Protect yourself and others from the damaging effect of compressed air. Inspect the air hose for cracks or other defects. Before opening the control valve, see that nearby personnel are not in the path of the air blow. Never stay near to compressed air. Do not turn the main air supply and make sure that the disconnected pipes are connected properly. Otherwise, disconnected pipe can whip around and cause injury. If air is leaking from a joint, close the air valve immediately. Always turn air off before altering the circuit. Keep your hands away from the piston rods and always wear personal protective equipment while working with pneumatic system. Let us have a look at the advantages of pneumatics. Pneumatics is popular in industrial applications as low-cost automation because of the following advantages are: air is available at free of cost. Air is available in unlimited quantity everywhere. Air can be compressed, pressurized and can be transported through pipes. Air can be exhausted to the environment without any harmful effects. Action is fast. Speed control is possible. System is overload safe. Air does not ignite. Simple in design and construction. Long life and low maintenance. Components are simple in design and hence cheaper. Now let us have a look at the limitations. Pneumatic system has certain limitations as follows. Pneumatic system is economical up to a limit of 3000 kg force per square centimeter. Pneumatics needed fine quality equipment to remove dust and moisture, air filters and demoisture. Air exhaust is noisy. Uniform speed is not possible. Special lubrication technique is required to avoid friction between internal components. In case of leakage, pneumatic system becomes costly and compressing air beyond 7 bar is costlier. Whenever you are working with pneumatic system, you must take following safety precautions. Take precaution against corrosion in pneumatics components. Do not use compressed air to clean body parts. Never use kerosene to clean pneumatic system. Compressed air does not ignite but can explode due to pressure. Pneumatic system operates at high speed. Most of the accidents happen due to crushing. Hence, take care when handling. Do not put hands in the path of operating components. Avoid contact of plastic pipes with sharp edges. Close main valve to unpressurize pneumatic system prior to maintenance work. Loose connection may cause withdrawal of pneumatic hose that whips due to airflow. This whipping action may cause injury. The key concepts of pneumatic system maintenance are troubleshooting, done in a logical manner, can solve most pneumatic system problems. Safety should be the first consideration when troubleshooting. Inspect the equipment, clearly understand and rectify the complaints with the help of operator. Once in a week, drain compressor, tank, filter, bowl and any air lines that have drain cocks. Check compressor crankcase oil level and compressor safety of relief valve. Once in a month, inspect discharge air filter and check pressure of reducing valve setting. Once in every 3 months, change crankcase oil. Oil the compressor motors and check compressor pressure switches. Once in every 6 months, check for moisture, oil and dirt in air lines. Clean the intake air filter, belt and screen types. Check the compressor belt, the pressure relief valves, calibration, operation, nozzles and restrictors of transient temperature controllers, pressure controllers, thermostats and humidistats, piping of pressure transmitters and controllers, and clean elements and humidistats. Once in a year, replace cartridge type intake air filters. Check calibration of receiver controllers and the valves for tight close-off.
We have reached the end of this session on safety procedures in pneumatic systems. By now, you should be able to follow the safety while working in pneumatic system, select the personal protective equipment, plan pneumatic maintenance practices, and select proper practices of pneumatic maintenance. Hello, welcome to this session on identify the parts of a pneumatic cylinder. By the end of this session, you will be able to identify internal parts of single acting cylinder, explain working principle of single acting cylinder, identify internal parts of double acting cylinder, and explain working principle of double acting cylinder.
Single acting cylinder is an actuator which moves load along the straight line. It can apply pneumatic force only in one direction, therefore called single acting. Movement in opposite direction is caused by external force like spring or own weight of the load. The main parts of the single acting cylinder are cylinder, piston, piston rod, seal, spring, and inlet port. Initially, the piston remains at the innermost position in the cylinder due to spring force. When compressed air is supplied through the inlet port, pressure acts on cross-section of the piston. Product of pressure and piston cross-section area gives rise to increased pressure inside and create a force that acts opposite to the spring force. If the pneumatic force is greater than the spring force, then the spring gets compressed and the piston starts moving. The seal prevents air leak across the piston. The continuous flow of air causes continuous motion of the piston. Load is attached to the piston through the piston rod, therefore, load also moves with the piston. Piston and load move till piston reaches to the other end. At the end, there is no further space for piston to move. Hence, piston and load movement stops. This piston movement is called forward stroke. In forward stroke, piston rod comes out of the cylinder. If pressure acting on the piston is released, the pneumatic force acting opposite to the spring becomes weak. Therefore, spring pushes the piston back. This stroke is called a return stroke. In return stroke, piston rod goes inside the cylinder. The double-acting cylinder is an actuator which can push and pull the load using compressed air. It has two ports for air supply. The main parts of double-acting cylinder are piston, an element which moves to and fro inside the cylinder. Cylinder that confines air for the piston movement. Piston rod that connects piston and a load. Piston seal which prevents leakage across the piston. Rod seal which prevents air leakage from cylinder to the atmosphere. Piston end is a part of the cylinder consisting air passage and connected to the piston side. Rod end is a part of the cylinder consisting air passage and connected to the piston side. Let us now look at the working principle of double-acting pneumatic cylinder. When air is supplied through port A, force is exerted on the piston so that it moves in the forward direction. This movement is called forward stroke. During the forward stroke, air already present at the rod side exhausts through port B. Piston movement will stop if the air does not exhaust. When air is supplied through port B, the air already present exhausts through port A and the piston retracts. Let us have a look at the pneumatic cylinder. Identify the parts, record and check it for your reference.
We have reached the end of this session on Identify the parts of pneumatic cylinder. By now, you should be able to identify internal parts of single acting cylinder, explain working principle of single acting cylinder, identify internal parts of double acting cylinder and explain working principle of double acting cylinder.
Hi everyone. In today's video, let us discuss how to dismantling and assembling of solenoid valve. At the end of this, you shall be able to remove the nut, to remove the coil, remove the core or metal plate, remove the valve, check for scratches, clean and reassemble.
Objectives. At the end of this, you shall be able to remove the nut, to remove the coil, remove the cores or metal plate, remove the valve, check for scratches, clean and reassemble. Let us discuss about solenoid valves. Solenoid valves are control units that, when electrically energized or de-energized, either shut off or allow fluid flow. The actuator takes the form of an electromagnet. When energized, a magnetic field builds up, which pulls a plunger or pivoted armature against the action of a spring. Direct solenoid valves. A solenoid and a valve body make up the two primary parts of a solenoid valve. An iron core known as the plunger surrounds an electromagnetically inductive coil at the center of a solenoid. It may be usually open or normally closed when at rest. A usually closed valve is closed and a normally open valve is open in the de-energized state. The solenoid's coil is energized and produces a magnetic field when current runs through it. This moves the plunger and displaces the spring force by creating a magnetic attraction between them. If the valve is ordinarily closed, lifting the plunger causes the seal to open the orifice and let the media flow through. The solenoid valve's magnetic force and orifice diameter have a direct impact on the maximum operating pressure and flow rate. Consequently, for relatively low flow rates, a direct acting solenoid valve is commonly used. Direct operated solenoid valves can be utilized from 0 bar to the maximum permitted pressure because they have no minimum operating pressure or pressure difference requirements. Indirect solenoid valves. The pressure difference of the medium over the valve's input and outlet ports is used by indirect acting solenoid valves, also known as servo-operated or pilot-operated valves, to open and close the valve. They normally need a minimum pressure differential of about 0.5 bar as a result. A diaphragm, which is another name for a rubber membrane, separates the inlet and output ports. A tiny hole in the membrane allows the medium to pass from the entrance to the top compartment. A typically closed indirect acting solenoid valve will stay closed as long as the inlet pressure above the membrane and supporting spring are present. A narrow passage links the low pressure port to the chamber above the membrane. The plunger and valve seal restricts this connection when the valve is closed. This pilot orifice has a diameter that is greater than the membrane hole's diameter. The pilot orifice opens when the solenoid is activated, which lowers the pressure above the membrane. The membrane will be elevated as a result of the pressure difference on each side of the membrane, allowing the medium to flow from the inlet port to the output port. The identical parts make up a typically open valve, which operates in the opposite manner. Semi-direct solenoid valves. Indirect and direct valve characteristics are combined in semi-direct acting solenoid valves. Because of this, they can operate at 0 bar while still having a high flow rate. They have a movable membrane with a tiny opening and pressure chambers on both sides, and they resemble indirect valves in appearance. The solenoid plunger is directly attached to the membrane, which is the difference. The membrane is directly lifted when the plunger is raised, opening the valve. The plunger simultaneously causes a second hole in the membrane, which has a slightly bigger diameter than the first orifice to open. As a result, there is a decrease in pressure in the chamber above the membrane. As a result, the membrane is raised by both the pressure difference and the plunger. This combination produces a valve that can manage reasonably high flow rates and can function at 0 bar. Semi-direct operated valves frequently have coils that are more potent than indirect operated valves. Assisted lift solenoid valves are another name for semi-direct operated valves. Selection of solenoid valve. Before choosing a solenoid valve, it is imperative to have a thorough understanding of your application. Type. Ascertain if a two-way or three-way solenoid valve is needed for your application. Input voltage. Depending on the availability of power supply, solenoid valves can be found in both AC and DC power supplies. Valve function. You have the option of selecting a generally open or normally closed valve depending on the operating time period. Most solenoid valves are typically closed while not in use. A typically open valve is recommended if the valve's opening time is longer than its shutting time and vice versa. And another choice is bistable or latching. Pressure. For your application, the valve needs to be able to resist the highest pressure possible. The minimum pressure should also be noted because a high pressure differential can lead to valve failure. Operation type. Determine the type of operation needed for your application, whether it calls for a direct, indirect, or semi-direct operated solenoid valve. Seal material. The chemistry and temperature of the media should be taken into consideration while choosing the seal material. Common choices include NBR, nitrile butadiene rubber, EPDM, ethylene propylene diene monomer, FKM, fluorine caustic material Viton, and PTFE, polytetrafluoroethylene Teflon. Refer for rapid access to information on seal materials, chemical resistance. Choose the appropriate seal material for your solenoid valve. Housing material. Based on the media's chemical composition, temperature, and environment, choose the material for the valve housing. Typically, brass is utilized for neutral media. The chemical, temperature, and pressure resistance of stainless steel is good. Because they are economical, PVC and polyamide are frequently used. Applications. Solenoid valves are used in refrigeration systems to change the direction of refrigerant flow. This aids in heating during the winter and cooling during the summer. Automation control solenoid valves are used in irrigation systems. Solenoid valves are used in washing machines and dishwashers to regulate water flow. Solenoid valves are used in air conditioning systems to regulate air pressure. In automatic locking systems for door locks, solenoid valves are utilized. The flow, direction, and pressure of the fluid are controlled by solenoid valves in medical and dental equipment. Solenoid valves are frequently used in conjunction with float switches in water tanks to regulate the inflow or outflow of water. Controlling the water and soap flow in car washes, equipment for industrial cleaning. Let us discuss in practical. Task 1.
Dismantling and assembling of solenoid valve.
Step 1. The assembled valve looks like. First thing to note is that the valve actually is two major components, the coil and the valve mechanism. You can safely remove the coil even while the valve itself is connected to the water supply and under itself is connected to the water supply and under pressure. Removal of the coil itself will not cause the water to flow and will not cause the valve to leak water. Step 2. Remove the top nut to remove the coil. For the following steps are disassembling the valve itself. For this, you need the water turned off and even then you will get a slight amount of water out of the system when you take the valve apart. Step 3. Here, note the two screws holding the metal plate on. We will remove these to disassemble the valve. Step 4. Now remove the two screws. Step 5. Now remove the metal plate. Step 6. Now with the twisting motion, grab the valve stem and pull it upward. The valve with the stem removed. Step 7. Now the stem itself can be disassembled and cleaned. Note that the plunger with the spring should just fall out of the stem. Step 8. Observe inside the stem and the surface of the plunger and clean any trace of foreign objects. Task 2. If you ever need to disassemble a A37 IRU ZZN0 AC 220 volt water or air solenoid valve, here is a step-by-step pictorial. Step 1. The front and back gate valves on the water solenoid valve's main valve should be closed. Step 2. To release the pressure inside the water solenoid valve, loosen the pipe junction screw on the main valve lid. Step 3. In addition to the nuts on the copper tubes in the control pipeline, remove all of the screws from the water solenoid valve. Step 4. Remove the bonnet and take out the spring. Step 5. Take out the piston, diaphragm, shaft core, etc. Diaphragm injury must be avoided. Step 6. After removing the aforementioned pieces, examine the diaphragm and O-ring to see whether they have any damage. Please put an end to disassembling the internal components if there is no damage. Step 7. Look closely to see whether the shaft core and primary valve seat have any damage. The water solenoid valve's main valve should be cleaned out if there is any additional junk within. Step 8. Assemble the components and pieces in the main valve in the opposite sequence. Please be aware that you cannot block the water solenoid valve.
I hope you can disassemble and reassemble the solenoid valves after watching this video. Thank you for watching and have a great day.
Today I am here to discuss about the effect of seismic load on a structure. Before starting our discussion, I would like to discuss about the various loads which may occur on any structure. First one is dead load. Dead loads are the majorly gravity load comes in any structure due to their structure